This is a continuation of Chapter 4, Section 9, Metric Measurements, and this is where we actually compare some different units, and we'll have to do some unit conversion to compare these different numbers that we're dealing with. So it talks about Sam's laptop computer has a mass of 4 2/10 kilograms. Fred's laptop computer has a mass of 4,940 grams. Which computer has the lesser mass? Explain your answer. Well, up here, I've given a base unit. So this one could be anything, either grams, meters, or liters. And then these are the different units that we either go up or down. Either the deci means it's smaller than one base unit by a tenth. Centi, like a centimeter, is smaller than the base unit of a meter by a hundredth. So it takes 100 centimeters to make one base unit of a meter. And it takes 1,000 millimeters to make one base unit. Here, the deca going the other way, this represents 10 meters, where a hecto represents 100 meters, and kilo represents 1,000 meters. And so it works with any type of base unit, whether it be the meter, the liter, or the gram. So what we're going to end up doing is we're going to try to compare these two. So what I need to do is just take one of the units, like let's say this 4 2/10 kilograms, and I want to change it to grams. So what I'm going to write down is 4.2 kilograms, and then times by a unit conversion. And so I want to cross-cancel the kilograms. So I'm going to put the kilograms on the bottom, and I want to change it to grams. I want to change it to grams because that's what these are. These are in grams, and I want to compare these two. So how many grams make a kilogram? Well, a kilogram is 1,000 base units. So that means 1,000 grams. And so from there, we can go ahead and cross-cancel the grams, and you see you just multiply. Now, when you multiply by 1,000, the decimal moves 3 spaces. So I move it over the 1 space, and then 2, and then 3 spaces. So that makes 4,200 grams. So now I want to compare the two, because I want to find out which has the lesser mass. So Sam's is 4,200 grams, where we have Fred's is 4,940 grams. So the one that has less is Sam's. So which is less? Well, Sam's is less. And the way I had to do that is I had to compare masses. So I'll say to compare mass, to compare masses, the units must be equivalent. That means the same. So I need those units to be the same, and we can see how Fred's has more mass. Well, the next one talks about Elise makes a poster that is 1 5/10 meters tall. Meg makes one that is 96 centimeters. Whose is taller? Well, we need to compare them, so we need to change them so that they have the same units. So let's change Elise's from meters to centimeters. So we want to cross-cancel meters, so we're going to put meters on the bottom, and I want to put centimeters on top. Now I put 100 because 100 centimeters is equal to 1 meter. See, it took 100 of these centimeters to make 1 meter, just as it took 1,000 grams to make 1 kilogram. And so 100 centimeters equals 1 meter. So the meters will cancel. Now I'm multiplying straight across. So the decimal moves 2 spaces. So moving it 2 spaces changes this to 150. So again, it was here. It moved over 2 spaces. So it's 150 centimeters. So we have Elise's, whose is 150 centimeters. And then we have Meg's, and hers is only 96 centimeters. So obviously we see how the one who's taller is Elise's. Hers is greater. And the reason is that we had to come up with comparable units. So we had to compare both units need to be equal. And so that's what we did. And we saw that Elise's is taller. Well, looking at our next one, it says Eleanor ran 3 5/10 kilometers on Friday, 2 8/10 kilometers on Saturday. Monroe ran 6,400 meters. Well, on the same 2 days. So who ran the greater distance? Well, let's take Eleanor, and let's find out how far she ended up running. So 3 5/10 kilometers. Let's change that to meters. So we do 3 5/10 times by 1 kilometer, down at the bottom to cancel those out, is equal to 1,000 meters. So that ends up making 3,500 meters, because we have to move that decimal 3 spaces because there's 3 zeros. Well, we have to do the next one, which would be 2 8/10 kilometers. We're going to multiply that by 1,000 meters again to change it to meters. And when we do that, we get 2,800 meters. Now we have to add those two together, because she ran both of those distances. And we go ahead and add those. And we end up having to carry a 1, and that makes 6,300 meters. But that is less than the 6,400 meters. So that tells us that Monroe ran further. Monroe ran further. And the reason is that 6,400 is greater than the 6,300 that Eleanor ran. So tunnel A is 1 6/10 kilometers long. Tunnel B is 740 meters long, so we need to find out which one is longer. So let's change the units. 1 6/10 kilometers over 1 times by the unit conversion. So we have 1,000 meters in 1 kilometer. And so when I go ahead and change that, I move that decimal 3 spaces to the right, makes 1,600 meters. So which one's longer? Well, definitely tunnel A is longer, but how much longer? So I need to take those two numbers and subtract them. And when I do that, I'll have to end up borrowing a few times. Change that to a 15, and we have to subtract. We get 860 meters longer. So we would say tunnel A is longer because 1,600 is greater than 740. And why is it, or how much longer? And we'll say it is longer by 860 meters. Well, next one says a mouse has a mass of 18 grams. A guinea pig has a mass of 8,500 grams. Is the mass of the two animals together greater or less than 1 gram? So let's go ahead and change them so that they're the same. So this time we're going to change grams to kilograms, because we need to see if they weigh a kilogram. So we'll do that by changing 18 grams and multiply. This time we want 1 kilogram on top, because that's what the unit that we want, and we want to cancel out the grams. So there's 1,000 grams in a kilogram. So I need to divide by 1,000. Well, that just moves the decimal back the other way. And so it moves it back 3 spaces. So you're going to end up moving it 1, 2, 3. So it's going to end up being 0.018 kilograms. So we need to add those two together now, because it says the mass of the 2 kilograms is what they want. And so we take that 0.018 and I add the 0.85. Now notice I have to line up decimals when I do this addition. And I end up with an 8, a 6, and an 8. So there it is. 868 kilograms is the mass of the two, which is less than 1 kilogram. So this isn't even 1. This is less than 1. Now how much less? Well, what we'd have to do is subtract. So if I subtract those two, I'd have to line up decimals once more and then do some subtraction. So I have to borrow all the way back, change these to 9s, and I end up with a 2, a 3, and a 1. So it's less by 132 thousandths of a kilogram. So there would be our explanation. Next one, it says the distance from Midwood Library to Midwood Middle School is 845 thousandths kilometer, and the other one is from Midwood High School to Midwood Library is 872 meters. How much closer? Which is closer, and by how much? Well, let's change this one right here. The middle school. We're going to change that to meters. So 0.845 meters, or kilometers it is right now. We're going to multiply that by 1 kilometer on the bottom and 1,000 meters on top, because 1,000 meters equals 1 kilometer. So we get those kilometers to cancel, and we end up moving that decimal 3 spaces makes 845. So which one's bigger? Well, 845 is less. Meters is less than 872 meters. So that tells us that the middle school is closer. The middle school is closer. Now by how much? Well, all we have to do is subtract. So let's do that. 872 minus 845. So we do that subtraction, borrow a bit, and we end up with 27 meters. So it's closer by 27 meters. There would be our answer. Well, those are the types of problems you're going to end up seeing on tonight's homework. Good luck.